Welcome to the fourth chapter on multibody dynamics using Alter HyperWorks Motionview Motionsolve. In this chapter, you will continue to build on the free body model from the previous chapter. We will assign initial conditions, that is, velocity to the body. We'll create an output for specific measurements of interest. We'll also learn about the coordinate systems and the markers. And we will also simulate and plot the results. So in the body panel, and if we go to the initial conditions tab, it will allow us to define the initial conditions of the body. If we put a check mark on any of these boxes, we can turn on the initial conditions of the body. The initial conditions of the body pairs are made symmetric by activating the symmetric properties button. So we use Vx, Vy or Vz to set the initial conditions for the translational velocity. We use Wx, Wy and Wz to set the initial conditions for rotational velocity. We use Vm to make the marker to specify the direction of the translational velocity initial conditions. We use Vm to set the marker to be used to specify the direction of the translational velocity initial conditions. And we use the marker Wm to specify the direction of the rotational velocity initial conditions. Now let's move on to one of the most important topics in MVD, which is markers and coordinate systems. So in the FEA world, we refer to the markers as systems, and in MVD, we refer to the coordinate systems as markers. So markers are nothing but coordinate system, which is used to uniquely measure the position of a geometric element. Motionview uses a Cartesian coordinate system. A marker is nothing but a coordinate system that is attached or fixed to a body. So we have different types of coordinate systems in Motionview. They are the global coordinate system and the local coordinate system. So this local coordinate system is again divided into two parts, that is the body coordinate system and the different markers. So now let's talk about the markers. So markers come under the reference entity, just like the points, graphics, bodies, etc. So I would like to discuss some key points on markers. Markers play a very important role for defining the local part reference frame for the rigid bodies, flexible bodies, and the point masses. They are also useful in specifying the connections in the constrained elements such as joints and motions. Markers also help in specifying the connections in the force elements. They act as reference coordinate systems for reference curves, reference surface, and post graphic. Markers are also useful for defining output channels for the measurement of displacements, velocity, and acceleration. So, if we have a body with marker M and we have another body with marker N, then if the body A's or body M's displacement has to be measured with body N, then it will be measured with respect to these two markers as shown in the figure. Hence, markers play a very important role in MVD. Now coming to the creation of markers in Motionview. So markers can be divided into two types: the implicit markers and the explicit markers. Implicit markers. Some markers are created implicitly when creating another body, such as bodies, joints, etc. They get created automatically. Implicit markers are quite useful for the measurements and the force definitions. Explicit markers are the markers which can be explicitly created in the marker panel. It can be created in the same way like how you create a point or a body, either by going to the model browser, right clicking, going to add, and then the reference entity, and then you can click on markers. And the second option is to right click on the marker folder in the model browser and just say add marker. And the third option is to select the marker from the client specific toolbar. So I'll show that to you in the graphical user interface. So the first option is to go to model, right click, go to add, and then go to reference entity and click on marker. This is one way of creating it. The second way is to click on either the folder or any of the pre-existing markers and then say add marker. This is the second way of creating it, and the easiest way is to just click on this option on the client specific toolbar and say OK. So when you add a marker, you get this following panel. This is the marker panel. So it requires a body on which the marker is fixed, the location for the marker, and also the orientation. So these three are the key points which are required when you create a marker. So if I go to the graphical user interface, so this is what I see. So I created here 3 markers. So I need to basically select its parent body. So right now by default we just have the ground body. Say OK. And by default we just have the global origin. So it gets created, and we should also define its axis. So its axis can be at a point, it can be along a vector, or it can be along this component. So these 3 entities have to be defined when you add a marker. So now moving on to the next slide, which deals with the markers in the body panel. So the body panel in Motionview will create markers for the body based on the data specified in the panels. So these markers will be implicit markers, which means that they'll be created automatically. So we have the center of mass marker, which is also called as the CM marker. We have the inertia marker, or the inertia coordinate system marker, and then we have the body coordinate system marker. Now let's see what these mean in detail. Center of mass marker. Only the location of the marker is used for the center of mass. Orientation is important if the inertia marker is defaulted to the center of mass. So here the location is of utmost importance. If you put a check mark in this dialog box, then the location of the marker becomes very important, but the orientation also becomes important if the inertia coordinate system is defaulted to the center of mass coordinate system. If the center of mass coordinates are not specified, then the center of mass coordinates of the body will be default to the global coordinate system. Inertia marker. The inertia properties of the body are defined relative to the inertia coordinate system. If the inertia coordinate system is not defined, Motionview uses the center of mass marker by default. And the reason is that the moment of inertia is a function of mass and the distance of the mass as measured from the particular axis, which is why the orientation of the marker is very critical for the definition of inertia. Body coordinate system. So this defines the local part reference frame, or the local reference frame for the body. This is used by the Motionsolve to compute the position as well as the orientation of the body. So please note that Adams, which is another Multibody dynamics software, it defines all the markers associated with the body with respect to the local part reference frame, that is nothing but the body coordinate system, whereas Motionsolve defines all the markers with regard to the global coordinate system. So this is the main difference between Motionsolve and Adams solver. So now let's just summarize the importance of marker. So the marker is basically the coordinate system that is fixed on a body. It's often created automatically. They are nothing but the implicit markers. Next point is every part has one to define reference for mass, inertia, etc. And the markers are also used by other entities like joints, forces, outputs, etc. Now move on to our next topic, outputs. So you can create outputs in Motionview in the same ways you created bodies, points, markers, etc. The outputs panel allows you to define what information is to be placed in the output file when the simulation is run. It's basically the user's request. What results we want to see once we run the analysis. That is defined by these outputs. There are basically 6 types of outputs that are available in Motionview. They are displacement, velocity, acceleration, force, expressions, and then the user-defined outputs. So I'll show this to you in the graphical user interface. So the 3 ways of adding the outputs: you can go to the model, right click, go to add, you can go to reference entity and see that you don't have any outputs here. So where can you find outputs? You need to go to the general MDL entity. So that's the reason you need to know all the 3 ways of creating an entity, so that you know a particular entity falls under which of these domains. Okay. So go to general MDL entity and then click on output. This is one way of creating it. Second way of creating it is if there's a pre-existing output, right click on this and say add output. Okay. And the third way of creating it is from the client specific toolbar, which is this option here. Okay. So once you create the output, this is the output panel, and these are the different types of outputs that can be requested by the user. And the outputs can be between the 2 points, it can be on a particular entity, or it can be on a particular entity set. So you can change that in this drop down menu. And then here we need to select body 1, between which two bodies you want to measure a particular output, and also define the reference marker and the point on body 1 and point on body 2. So all these options need to be resolved before requesting the output. And then here we have this particular option wherein we have the eye marker. We can either request the output just on the eye marker or just on the J marker, which is nothing but the marker on the body 1 is the eye marker, the marker on the body 2 is the J marker, or you can request the outputs on both, okay, with respect to both the bodies. So these are the options available after creating the output. Let's go back to the presentation. So I'm trying to explain the same thing here, whatever I showed you in the graphical user interface. So here, if you pick 2 points, then it is for measuring displacement, velocity or acceleration between 2 points and not to forces. It's not applicable for forces there. If you pick entity, then it will pick just one entity to measure any of these parameters. And if you pick an entity set, you need to pick one entity type, like for example bodies, to measure, and Motionview will create outputs for all the same type of entities that are present in your model. The second thing is, outputs can also be defined by using expressions. Up to 6 independent expressions can be entered per output in your output panel. And outputs can also be user-defined or subroutines. So the user-defined output is requested by entering a subroutine parameter in a text box that calls a solver request subroutine. So the function types can be written in the following scripts. It can be either in Fortran, C++, C, Python or MATLAB scripts. Okay. Now it's time for me to do the demo on exercise 4. Now let's continue with the demo on exercise 4. Let's open the model that we had created in the previous chapter. So we can either go to chapter 4 exercise start, or we can go to chapter 3 exercise completed. So either of the two should do. So I'll just bring up this model, which is where we had stopped in the previous class. So now for this free body, I'll be giving it some initial conditions. Okay, you can click on the free body in the model browser and then go to the initial conditions tab. You can put a check mark in the Z direction, VZ. So we are basically giving it a translational velocity in the Z direction to set the body to have an initial velocity going up. So, and the units and the value I'll be giving it as 1000 millimeters per second going up. So this is the initial velocity that is given to the body. Now let's create an output request. So we can go to this particular icon on the client specific toolbar. We can leave the defaults as it is. So the type of output request that we are requesting is the displacement. We want the output to be on an entity, and that entity should be a body, which is nothing but the free body. So we are requesting the displacement of an entity, which is this free body, in the global reference frame, and here we'll be keeping the option as both. So many of the entities in Motionview or Motionsolve, they require markers to define them, which include an eye marker on one body and a J marker on the other body. For example, measuring the displacement between the two bodies will be measuring the displacement between the eye marker of one body and the J marker of the other body. So this drop down menu here, it specifies whether the output measurement should be of the eye marker on the body or the J marker of the body with which we are measuring with respect to, or both. So here I'm selecting both, and now I'll be running the simulation. So I'll save this as chapter 4 exercise complete, save, run. Okay, it's complete now. Let's close this. Go to the plot option here, which brings up HyperGraph, and here you can try two things. The first thing is click on the free body and the y component is the z direction, and click on apply. You can now see that the body is going up and then it is coming down under the action of gravity, and the body here going up is because of the initial velocity that we provided in the z direction. Okay, so now let's see what difference is there between this curve and the marker displacement that we've created. So technically they should be the same. So let's verify. Go to marker displacement on the free body, and in the y component I'll select dz and say apply. So here if you zoom out and see, the curves look like they overlap each other. But if you zoom in, you can see that there's actually a difference between these two curves. I hope you're all able to see that. Okay. The graphs are nearly coincident but separated by a y displacement of 5. Okay, which is the z difference between the center of mass, which is at 5, 0, 5 in the Cartesian coordinate, and the body coordinate system, which is located at the global reference frame 0, 0, 0. Okay, to set this right, okay, to correct this, what we need to do is we need to set the body coordinate system to have its origin at point 2, just like the center of mass. So let's do this. We will change the body coordinate system of this body to point 2. So this will change the Motionsolve default output to measure at the center of mass for this body instead of at the ground point. Let's do that. Let's go back to Motionview here and let's click on the free body. So to bring up the body panel, here let's go to the body coordinate system and put a check mark on use the body coordinate system. You can see that this marker comes and sits on top of this point 2 now, after I give the origin point as point 2. Okay, you can now see that. So now it's perfectly aligned. So once this is done, you can run the model again and compare the results. So let's go to plot. Okay, so first I'll plot the body, free body in the z direction. We have this curve. Now I'll go to the marker displacement on the free body and the y component is dz. Say apply. Now they should exactly overlap on top of each other. Yes, and we can see that happening. So I hope you got the difference between what happened earlier to this plot. Okay, so this brings us to the end of the demo on chapter 4. Thank you.